Good afternoon, everybody. My name is Attila Nagy. I'm working with Supermicro. Actually, I work with Neuwold. Neuwold is a local manufacturer for Supermicro, and for business is the sales branch for Neuwold in Brazil. Personally, in the recent past, I have worked with HPC clusters, helped build a few of them, including the two largest in Brazil, in Latin America, Grifo 04 and Grifo 06, which are clusters installed at Petrobras. So let's go to the subject. You probably have seen these charts this morning already, so you may be saying, wow, I have to watch the same slides again. But the point I just would like to make here is that all the industry standard, the commodity-based components still make up the most of the HPC systems in the world. These are top 500 numbers. So cluster architecture is in most of the systems. Processors are x86 based in a great majority. Interconnect is InfiniBand and Ethernet with a mix, and 10 gigabit Ethernet coming in the more recent years. And operating system that's kind of obvious is Linux throughout most of the HPC systems. So what I just wanted to summarize here is that commodity-based HPC is still the way to go, and the numbers from top 500 confirm that. And that results in basically x86 servers, InfiniBand and/or Ethernet interconnect, and the Linux environment. So, just a drawing of a typical HPC cluster. You see the network, probably more than one network on a real world InfiniBand HPC cluster. So you would have Ethernet even if you have InfiniBand, and perhaps even an out-of-band management network, which becomes important in very large clusters. It's important, probably always, but in very large clusters for management and control of the whole system is very important. And one important, maybe additional place where x86 servers are being used and now are mainstream is the storage part of HPC. If you look not many years back, like 5 or 6 years, you will see that even HPC systems had to resort to either proprietary storage systems or even enterprise class storage systems, which are really way too expensive for this use. Nowadays, you can use x86 servers as the base for storage nodes, and that's being done everywhere. So, just to conclude that the concept of those NASA guys 20 years exactly ago, the Beowulf cluster still stands. Actually, stands more than ever nowadays. Okay, so you might have been asking, well, won't you talk about coprocessors in terms of trends or accelerators? Yeah, sure. And you have seen this chart probably in a different way today already. But if you just look at it static, in a static way, you would say, well, it's just 10%. 90% of the systems in top 500 do not use accelerators yet. So, but that's a clear trend. My graph does not show actually the trend, but it's out there, and almost, I mean, probably everybody today will talk about GPUs and coprocessors source here. And one important thing, and that's probably the main reason for that, is that the path to exascale, just paraphrasing Arnaldo's speech this morning, has to go some way through some sort of coprocessing or acceleration. And that's for performance reasons and for power reasons. The power density is coming to extremes, and with the traditional CPU processing, we would end with uncoolable systems, if that word exists. So that's not a coincidence that the 10 top systems in the latest Green 500 are all coprocessor based accelerator, actually NVIDIA GPUs in that case. But it could be Xeon Phi as well. But the latest top 10 systems in Green 500 are all GPU based. That's certainly not a coincidence. The number one system, now I have to make a point here, is Supermicro server based. It's located in Japan. It gets 4.5 gigaflops per watt. That's a number that per se perhaps doesn't mean much, but for comparison, the number one system in the top 500 makes 1.9, so it's less than half of that. But it's not a bad number. 1.9 gigaflops per watt is a good number. But the number one on the Green 500 of more than double of that proves that there is room for improvement, and that's going to happen for sure. The other thing about the top 10 Green 500 that is important to mention is that 2 of them are petaflop systems. One of them more than 2 petaflops, and the largest one 6 petaflops. So that also means that it's not just a theoretical thing that just small, specially built clusters do that. You might think that, but the numbers prove the contrary. So that's really a trend that is irreversible. You can get, of course, these numbers can vary a lot, but if you analyze the top 500 and the Green top 500, you can see various examples where you can get up to 5 times improvement in power consumption, in space, in real estate, which is another aspect that many people ignore, but it's extremely important, and of course cost. So these are not small reasons for going towards that, the heterogeneous computing, in other words. And this is the other side for the 10% of actual systems now with GPUs. More than 80% of all HPC users are at least testing or in some way working with GPUs. So it's undeniable. Okay, but this is all about better efficiency, but still, let's take a look now at some numbers regarding exactly how much electrical power generally data centers consume. These numbers here, of course, are not HPC systems only. It's data centers all over the world. But if you think that 1.3% of all electrical energy produced in the world is consumed by computers in data centers, servers and storage and everything, that's incredible. I would mean, for example, aluminum industry consumes incredible amounts of electrical energy, and that's included in the 100%, from which we are taking 1.3%. In the US, it's 2%. Well, that's probably understandable because of the number of systems and everything. But still, you can see that if this trend continues, and now we can have a look at a trend here, that was more an absolute number. The data center power usage growth worldwide was 7%. In Brazil was 10%. US a little less, and generally the developed economies are not showing that much of an increase. That's for several reasons, but one of them is that the data centers are becoming more efficient. And that trend has some lagging in terms of going into the emerging economies like Brazil. But in these numbers, the average of 7% is small compared, it's a slowdown actually, because the previous year, if we take the growth from 2010 to 2011 to 2012, the growth was twice that, like 15% worldwide. So that's something that has to be addressed. Of course, as I said, HPC is not all of that, but it certainly follows a similar trend. And, well, of course, this is kind of obvious, but cooling, real estate are issues that come with power and the growth of systems. And management, actually management is, can be seen as a problem in large systems, but is a way to the solution as well, is a path to the solution. But what everybody is trying to do, and that's true for enterprise data centers, true for Google, Yahoo, Microsoft, Facebook, the gigantic data centers, and it's true for HPC installations. You want to save on operating expenses that can be in some systems so large that they surpass the acquisition value of the systems. So what's the roadmap? What are the ways to go to a higher efficiency HPC systems? What's the roadmap for Green HPC? First and foremost, this was discussed not just by myself here, is processing efficiency. heterogeneous computing is the way to go. We already talked about that. But there is a component of that which is not only just, okay, I would like to use GPUs in my HPC system, but the server design has to follow that. So that's an important ingredient. The servers that will be the nodes of your HPC cluster have to have been designed in a way to use all the features and all the advantages that the new technologies are bringing, like the ones mentioned by Arnaldo, for example, this morning. A little bit more about server design. Power supplies mainly in a server. You may think it's a trivial thing, but power supplies are not 100% efficient, of course. In recent years, power supplies have improved a lot, but they are still an aspect of very much attention in terms of the people who design servers. And the efficiency is high, but some aspect that sometimes is ignored is that efficiency has to be high in all loads, not in full load of the server. Many times a cluster is not working full load. It's working with a low load. And as you can see, we can have here, anyway, even a platinum 80 plus is a measurement of power supply efficiency. Even a platinum grade power supply with a 20% load will have an efficiency of perhaps below 90%. There is a new grade of power supplies, which is the titanium grade, where you will hold 95, 96% efficiency, even in loads as low as 5%. This is also added to other things like low harmonic distortion of the current of the power supplies and high power factor. These are all important for the data center design. Thermal, of course, we are talking about very high power densities. So the thermal design of a server has to get very careful attention. Airflow, fans, heat sinks, and the mechanical design where the objective is to get the highest density, but still with respecting the other dependencies of power and thermal, and even the endurance of the components of the server. I have here, just for your analysis, a breakdown of power consumption of a typical cluster. Of course, I have to make some disclaimers here because it's not very easy to generalize something like that. But this is based on real measurements of a previous generation system with Sandy Bridge Xeon CPUs and Fermi NVIDIA GPUs. But it was extrapolated to today's generation of Ivy Bridge and Kepler GPUs. You can see that 50%, as probably would be expected, is for the GPUs, 25% CPUs. But you can see that the fans and the power supply combined take 12% of all the power. So you can see that that's not, perhaps it's not an obvious thing. Just a remark that This is with a load, a synthetic load that tries to load the GPUs and all the CPU cores maximum. In a real system, of course, it will depend on how well the applications are optimized, if they run more in the CPU or the GPU cores. It probably will be very difficult to have full load on the GPUs and the CPUs at the same time. Here you have that because it's an artificial synthetic load. And the data center design as a whole is, of course, very important. PUE, if you are not familiar with the term, is the ratio of the total power that enters a data center to the power that is really used by the servers. And a PUE of 2, that meaning half of the energy is wasted, if we can say, in cooling, distribution, everything, is very common. So this is an area for much improvement. Several things, of course, the most trivial are layout, where you have the cold and hot IOs in the data center. But now we are going to more sophisticated things like liquid cooling, which have been mentioned here, but there are several ways to do it, but some of them even put the servers in the whole servers in a dielectric fluid, and you can achieve PUEs of 1.1 with that, which is way much improvement for above a PUE of 2, for example. And management as a whole is important to have all these things working together in harmony in a data center. Just a little bit about Supermicro. So Supermicro's products are actually designed taking into account all these principles that I have just mentioned, and optimized with a broad range of options for all needs of particular HPC use. And Supermicro is really involved in driving the Beowulf concept forward and practicing it. Thank you.